Today I will discuss the graph of a polynomial. Watching the graph, how we can say or know the zeros of a polynomial. Okay, so you see, this is a coordinate plane. Y dash, xo, x dash. Okay, this is suppose a polynomial, graph of a polynomial. So you see the graph of the polynomial intersects the x-axis at 1, 2, 3, 4, 5 points. No? So how many zeros the polynomial will have? The polynomial will have 5 distinct zeros or roots. Distinct means different, not equal. Okay, all the zeros are different. So 1, 2, 3, 4, 5 points. The graph of the polynomial intersects the x-axis at 5 points. So the polynomial will have 5 distinct zeros. Okay. So if a polynomial does not intersect x-axis at any point, suppose this is a polynomial, this is the graph of a polynomial, and this graph does not intersect x-axis at any point, na? So it does not have any real zeros. Okay, similarly, say this is a graph of a polynomial, and since the graph does not intersect x-axis at any point, so the polynomial does not have any real zeros. Okay, so to get the real zeros, the graph of the polynomial must intersect x-axis. Okay, now you see ax squared plus bx plus c, it is a quadratic polynomial, standard quadratic polynomial. Okay, and the graph of the polynomial is always a parabola. Okay, always a parabola. Parabola shape is this. Na? These are parabolas. And you see the graph of this quadratic polynomial is a parabola. So if a greater than 0, then graph of the parabola will be like this. This is parabola concave upward. This face na, is called concave face, na, and this bulging is called convex face. Okay, so you see, if a greater than 0, then the graph of the polynomial, that is quadratic polynomial, will be a parabola concave upward. Okay, similarly, if a less than 0, then graph of the quadratic polynomial is a parabola concave downward. Okay, let us take an example for our better understanding. X square minus 3x plus 2, say this is a quadratic parabola. So if I factorize it, we will get what? 1, 2. Okay, Now you see, that is, this quadratic polynomial will have two zeros, 1 and 2. This is, if I write this is equal to 0, then x is equal to 1, x is equal to 2 will get. Okay, so x is equal to 1, x is equal to 1, x is equal to 2. Okay, x is equal to 1, x is equal to 2. Now, and now if I put a value in between 1 and 2, 1 and 2, in between 1 and 2, that is 1.5. If I write 1.5, then what will happen? We'll see. It is 0.5, it is minus 0.5. So ultimately value is negative. Na? 0.25. So negative value. So ultimately negative value. Actually this one is what? Y. If I take y, na, then what will happen? If x is equal to 1, y is equal to 0, that is 1 comma 0, this is 1 point. If x is equal to 2, y equal to 0, this is another point, 2 comma 0. Na? When we draw, that is graph, na? 2 and 0. So if x is equal to 1.5, we write this mid value, then y value is this. So ultimately 1.5 x value and y value negative. So ultimately another point is coming here. So ultimately the graph will be concave upward. If this one you see a value here, na, it is nothing but a value 1 here, na, and it is positive, na, positive, na, it is greater than 0, na. So when a is greater than 0, then graph is concave upward. Okay, now you see, if I write like this, na, negative, na, x squared, na, that is a value here negative, then what will come? This one. If I factorize it, na, if I factorize it, na, then we will get this one. Okay, now minus plus. Okay, here also x equal to 1, you see, x dash, y dash. If x is equal to 1, then y value what we will get? 1 minus 1 0, so I will be 0. X equal to 1, y value 0. And if I put x equal to 2, then also y value 0. X equal to 2, y value 0. Okay, now if I take 1.5 middle point of this, then y value what we are getting? 0.25. That is 1.5, x value 1.5 means y value, x value 1.5 means y value, x value 1.5, y value is 0.25. So point we will get here. So ultimately the parabola will be concave downward. Now, so if negative, if a value is negative, that is, na, a value minus 1, negative, so less than 0. If negative value, then less than 0, that is a is equal to less than 0. So if a less than 0, the parabola will be concave downward. So you have to remember this. Okay. Now one more thing you will see. How many zeros will this polynomial have? You see, to get the zeros, we write, in the previous lecture I showed you how to find out the zero. Okay, to know how to find out zero, you see my previous video, na, polynomial class 10 part 1. Okay, so x squared is equal to, we are getting minus 1, so x is equal to plus minus, na? So under root of minus 1 is not a real number. So under root of any negative number, any negative 5, -5, -6, anything is not a real number. So the zeros of this polynomial are not real, and since zeros of this polynomial are not real, so the graph of this polynomial cannot intersect x-axis at any point. Similarly, you see this is a polynomial, cubic polynomial. At how many points does the graph of this polynomial intersect the x-axis? Okay, so watching this one, you cannot say that it will intersect x-axis at 3 points, and watching this one, you cannot say that that this polynomial will have 3 real zeros, or 3 zeros. Okay, so just watching this we cannot say. Here you see, to get the zeros you write this one, and x cube plus 1q is equal to 0. If I write the formula x plus 1 x squared minus x plus 1 is equal to 0. So either or if I write, then x plus 1 is equal to 0, or either, okay, x squared minus x plus 1 is equal to 0. This is minus 1. Okay, so one thing you have to remember, in quadratic equation you will learn, you just compare this with the standard quadratic polynomial. Okay, this one. Okay, so here a value is what? 1. In place of b minus 1, and in place of c what? 1. B square minus 4ac you write. B is equal to minus 1. A is equal to what? 1. C is equal to minus 1. So it is 1. It is A is equal to 1, C is equal to 1. So it is 4. So ultimately minus 3 less than 0. Whenever this is a quadratic polynomial and you compare this polynomial with don't think this 0 you don't consider here. This is a quadratic polynomial. You compare this quadratic polynomial with the standard quadratic polynomial, and then you will get a equal to 1, b equal to minus 1, c equal to 1. And if b square minus 4ac you find less than 0, then this polynomial will not have any real zeros. Okay, any real zeros. So only one real zero you are getting from this polynomial, and hence the graph of this polynomial intersects the x-axis at one point only. Okay, this is very important to know this. Just watching the degree, we cannot say that the graph of the polynomial will intersect x-axis at 3 points. We have to know how many real zeros this polynomial will have. The number of point at which the graph of the polynomial intersects are equal to the number of zeros. Okay, the numbers of point or number of point, the graph of the polynomial or graph of a polynomial intersect x-axis is equal to the number of real zeros the polynomial has. Okay, so we have understood how to know the number of zeros watching the graph of a polynomial. Okay, watching the graph of a polynomial. This much. Thank you very much.